Hello guys, we begin. In the previous video, I talked about system and system engineering in a nutshell. In this session, I will give you a brief introduction about model and SPES framework or method. Well, let's start. A model is an abstract description of the reality. With another words, short summary of something. Model abstraction is a way to simplify the model isolation some essential characteristic from a point of view. Depending on your point of view, you can abstract different characteristics. For example, for a designer, it's no matter how the components of a system communicate with each other or which network they use. No? But the appearance or the probably the functionality of the things uh, are the things they consider or they care. No? In this point, I want to talk about viewpoints. From a certain perspective or a certain point of view, you consider the things if they are relevant for your point or your perspective. If not, then you don't consider them. In that way, you simplify the whole system or the overall scope. You just consider what's relevant for your viewpoint. Now, we can jump in SPES framework. The goal of SPES method is splitting a complex system in small parts to process them in different granularity layers or granularity levels, from coarse to fine, as you can see in this SPES matrix. No? First, we handle them roughly, then step by step, diving in more details. That's the principle of SPES method. All right, what's all these viewpoints? First, functional viewpoint is describes the yes, it's considered the functional perspective, and it enables to describe functional behavior of a system. Logical viewpoint, where the architecture of system and its subsystems are modeled. It's crucial of it's for the white box of functional development. What's white box? White box mean that the things happening in background. With another words, the user doesn't realize what's going on, like signal translation between the components and so on. In that point, I want to touch black box as well. Black box is the opposite of a white box. The user realize what's happening. For example, when the user press the start button, then he's waiting that he's expecting that he or she is expecting that the display is going on. No? Yeah. The next is the technical viewpoint. We could consider that as hardware architecture. The components and subsystems of a system are illustrated with their communications and interfaces. The last viewpoint, actually, it's the first viewpoint, but I have saved it for the last on purpose because at the end I want to talk about requirements a bit. Now, it describes what the system has to accomplish. It is crucial for the traceability of viewpoints. What the heck is a requirement? Yeah. A requirement defines the needs of the stakeholder, what should be implemented, and how the system should behave. Nah? Sorry for my headset. Okay, there are different kinds of requirements: functional requirements, non-functional requirements, constraints, and capability requirements. Functional requirements describes the input-output behavior of a function, as you can guess from the name. And non-functional requirements describe the quality and characteristics. Constraints are the set conditions during development. Capability requirements describes the stakeholder demands to perform a certain functionality. Yeah, sorry. There are some rules how to write a good requirement. However, in this session, we will not address this issue. Maybe in next video. That's it for today. Thanks for watching. Take care.